Just without saying anything, without yelling anything, just in your head, think to yourself what the answer to the question I'm about to ask you is. Rational or irrational? Rational. Why? Integer over integer, yes? No problem, right? Okay. What about this one? Rational again, yeah? Because that is really 9/4. Yeah? Right? Okay. What about this one? Sorry. Mm-hmm. Yes, thank you, Joseph. Isn't this 1.2 divided by 4? Yes. And isn't 1.2 1 and 2/10? Yes. And isn't 1 and 2/10 12/10? Yes. And isn't divided by 4 the same as 1/4? Yes. Multiplied by 1/4. So isn't this 12/40? Everybody good? All right. Now, the reason I bring this up is because most of you will focus on that definition. Right? Which is why I assume a great many of you are like, nah, because that's not an integer, is it? Right? If you look back and you look at our first three here, natural numbers, whole numbers, integers, what was missing? That's supposed to be one of those stupid there. There's no decimals and there's no fractions until we get to rational numbers. Everybody cool? Yeah. Now, I know that none of you think of this all the way through to this point. When you see that, right away, you're going to go to your calculator, 1.2 divided by 4. Yeah? And you're going to get whatever that decimal is. Well, that decimal is 12 divided by 40. Everybody cool? Once, twice, thrice? Okay. So that leaves us at the irrational numbers. Now, we've covered all the numbers we count with, 1, 2, 3, 4, up to infinity. Then we added 0. Then we added all the negatives. Then we added all the fractions and all the decimals. So what's left? Everything else. Now remember, when we talked yesterday, 1, 2 on the number line, easy peasy lemon squeezy, until about grade 3, when your teacher told you that between 1 and 2, there's infinity again. Right? And that's easy to prove, correct?
2 seconds.
Yeah. You need me out there? Or? Okay.
Sorry, guys. Michael Logan, real quick, he's talking about measurement unit. I've got him.
Yeah, he's already done a retest on it. So what do you guys want to do? Like,
I don't know.
Like,
does he need more help with it?
He doesn't. I don't know. He doesn't.
Like, he hasn't worked with me on it yet, so I can go over with him. So
I
is there
would.
a specific thing to go over him with?
It's all formulas, Jazz.
Okay.
I mean, it's
okay.
Unless he can recognize that there's two faces and sometimes not.
Right.
Right.
So
Like,
does he have a book or something like that?
he's got his workbook.
Okay, so just go over the measurement unit, like which chapter?
It's the whole. It's the first 20 pages. Or
First 20 pages.
Yeah, something like that. It goes to the thing that says measurement review.
Okay, so I'll go over that and then I'll see what I see. No.
Okay.
Okay. Thank you.
This is easy to illustrate, right? If I go halfway to 2, I'm right there, yeah? Then if I go halfway again, I'm right there, yeah? If I go halfway again, I'm right there, yeah? Will I ever get to 2? No. Because I can always cut the distance in half again. Even when it gets to such a small distance that we can't even fathom it, I can still cut it in half. Theoretically speaking, right? We all understand that. If I was going to walk to Moret and I walked half the distance and half the distance and half the distance, eventually I would smack into Moret, right? But in theory, in numbers, will I ever get there? No, which is why we can say there's infinity between 1 and 2. Now, because infinity lives between 1 and 2, we have to have another category to cover all those numbers. And that's where rational numbers and irrational numbers come into play. Now, the most famous irrational number we already know, we've talked about it already this year, is pi. Right? Pi doesn't end. There's computers that have been dividing the circumference of a circle by the diameter of that same circle for 50 years. And they just keep getting decimals. There's trillions of decimals to pi. It hasn't repeated yet. It's not going to. I don't mind saying that it's not going to, but one shouldn't say absolutely that it's not going to, but it's not going to. Okay? That's the most famous one. There's another one. If you've seen it on your calculator, some of you wanted to use it when we were doing exponents. E with a little x over it. Pi is approximately 3.14. E to the x is approximately, and I should have done a squiggly equal sign, it's like 2.78. And we use it in finance a lot. You guys won't see much of it. You guys won't use a lot of that for quite some time. You've already used pi. The other irrational numbers that you're going to use plenty of are these. Square root of 2. What's that? Use your calculator. It's 1.414, blah, 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 right? Punch it in. 2153556, and then your screen ends, right? It doesn't matter. Your screen ends, yes? This number goes forever. Okay? If you hit square root and your screen fills up, you have an irrational number. But you need to be careful. Okay? If this is the edge of my calculator screen, right there, right? This would all be gray. That's an irrational number. My screen's filled up. It doesn't repeat. But what if it was this? The 5 and 6 weren't there. My gray edge is right there, and I had space over here. What's that? That's rational. Does everybody understand? This is rational because it ends at 3. The screen doesn't cut it off. It ends at 3. Everybody cool? Okay, now let me ask you this. What if I didn't punch in square root 2, but I just typed that into my calculator? Rational or irrational? Rational. Why? Because I ended it at 6. Everybody understand? Like if your calculator showed 14 digits, and there are calculators that do so, and I ended at 6, that's a rational number, right?
Yeah. So isn't it possible for it to repeat off your screen though?
I was just going to get to that. We're going to talk about that right after I say what I'm about to say. This is rational because this is 414, 215, 356 over... It's 414,215,356 billions. A very tiny number, yes? But rational. Now, Joseph has asked the question, since my calculator screen ends there, if I do square root of 2, and it goes on, Joseph says, well, how do you know it doesn't repeat later on? Well, you don't. Except that there's been lots of math research done with these square roots, with millions of them, to show that the numbers keep going and going and going. So they are deemed to be irrational. Now, I think the reason Joseph is asking that is the next thing I'm going to say. If I wrote 1.2375789 ... what does that appear to be? Irrational, because it doesn't repeat there, and the dots mean it continues. But there's no way to know for sure, is there? Because I did not put a square root in front of it, right? So that might very well, the 457,000th decimal place might start 2375789. It might start repeating. Does everybody understand? So questions like this, they appear to be irrational, but we cannot be sure unless we have put a square root in front of it and it's filled up. Everybody good? Now, even that can be a little dodgy, but for our purposes, that'll be fine. Now, let me ask you this. Is the square root of 4 rational? Of course it is, because what is it? 2, right? Okay. What about the square root of 9? 3. It's rational. Okay. What about the square root of 1.44? It's rational because it is 1.2. Now, a great many of you went to your calculator to solve that, yes? But there is no need to go to your calculator to solve that because, of course, this is 1 44/100ths, correct? Which is 144 over 100, correct? Now, I want the square root of that. Wouldn't that be the square root of 144 over the square root of 100? Which would be 12 over 10, which would be 1.2. Everybody good? Everybody comfortable with all 5 of these? We're never going to talk about them again, really, after today. They come into play when you're making graphs and things. For example, if I was going to be graphing the time that you spend in math class, would I ever need integers? I would need integers. Would I ever need negative integers? No, because you can't spend negative time here. Picking up what I'm putting down? Right? Okay. If I were to put on a graph the amount of children in this room, would I ever need anything other than whole numbers? No, because I cannot have a third of a child in this room. Does everybody understand? An arm and a leg can't come walking into the room. Everybody cool? Now, somebody always says here, some wise ass always says, well, what if a person had their legs cut off in an accident and they rolled in here on a wheelchair? That's still a person. Okay? You're not a person if you're missing a part of your body. And they still get mad at me for that. And then I always ask this question, or I always say this. Every single one of you in this room has more than the average number of legs per person. Right? Because you all do. Every one of you has 2 legs, right? The average number of legs per person on the planet is less than 2. Because, of course, there are many people on the planet with less than 2 legs. So the average is 1.95. You all have 2 legs. So technically you're all freaks because you have more legs than the average person. Right? Which is a very stupid thing to say, isn't it? But it also shows how easily statistics can be used to make you think you're dumb. Because I usually ask this question, I say, tell me why this is true. And everybody goes, Abe, it takes the whole class. I usually do it on a day when I don't feel like teaching. And the whole class, they sit there. And then they yell and argue, and then somebody starts in with well, if you have less than if you're not a full body, you're not a full person. It's a good time. But not today. All right, everybody is good? Good. Turn the page over. It's Friday. We'll probably get around to something like that. The other class had 20 spare minutes.
Wow. 20? Oh.
Of course, we're... Yeah. So, All of you already know how to do this because we've already done it today, right?
Yeah.
What is that really? It is 12 over 100. How do you know it's 12 over 100? There's only 2 digits there. Why has this got 3?
You times it by 100.
Yeah, I know, right?
Times it by 100.
This is awesome.
You can
Sarah.
put decimal place twice.
Because it's the hundredths, right? Now, why is it the hundredths, though? Because on this side of the decimal, it goes units, tens, hundreds, thousands. Why on this side is the first one tenths? Yeah, units are whole things, right? I can't split 1 into 1, right? I got one hand here. I can't split it any smaller. So that's why we don't have the ones on this side of the decimal place. That's why that's tenths. And then the next one is hundredths. So that's why I need it, right? Now, of course, would you ever tell me that that is the final fraction for 0.12? No, what would it be? 6 over 50. Would you ever tell me that was the final? No, what would you be? What would it be? 3 over 25. Right? Everybody's cool there, yeah? All right. Now, in B, something weird's going to happen. And half of you are going to know the answer to B right now. But I'm willing to bet my entire bucket of gummy bears that you cannot tell me why it is that. So, would anybody like to take that bet? That means if you can't explain it, you have to bring me a bucket of gummy bears. You know that, right, Dan? Okay. Would anybody like to take that bet?
I don't have money, so I can.
Yes, we're well aware of that because you still don't have a haircut. Right? 24 hours later, still no haircut. Oh, thanks, Gervier. I know he did. I know. That's why I said thanks. My daughter said that I should just say to you guys, when you ask me why do I bang on my desk, my daughter says, you should just say to them, why aren't you banging on your desks? I was too tough on you. You got to go back there, so you got a buffer zone?
Yeah.
Oh, Muffin. Are you sure? There's a roll of paper towel right there, buddy. Careful there. Sometimes that can make your nose hurt when you rub your precious little nose instead of using Kleenex with lotion in it.
I need a whole box.
Uh-huh. Doesn't surprise me. All right. All right. So, people that have been taught this trick, what is the answer? Dan. 1 over 9. Right? And if you go to your calculator, indeed, if you go 1 divided by 9, you get 1 for how long? Forever and ever and ever and ever. And you should be laughing at that because you all should know how much I love iCarly.
You never told us.
You're supposed to know that stuff. How can you not know I don't love iCarly? I have mentioned it many times. iCarly is one of the heights of comedy. I love iCarly. Oh, I love them all. Everybody on that show is awesome. When Gibby showed up on the Goldbergs, my whole family, because we watched the Goldbergs, then Gibby showed up on that, we were literally doing cartwheels. We even watched that horrible Gibby movie where he was the spy. Some of you have seen that movie. Ellie's like, you've seen it? You can be honest. I watched the whole thing. I can't even remember what it was called, but he was a spy. It was awful, but I watched it. I watched that movie Between, or whatever it's called, that TV show Between, where everybody in the town who was over 21 died of a virus because Jeanette McCurdy was on it. For like 2 episodes. I watched it anyway. I even watched some Victorious because there was one crossover episode with iCarly, and I was hoping there would be more. I even watched a bit of Sam and Cat. That's how much I love iCarly. I'm waiting for Jerry Traynor to get another job. Spencer. See, I even know their names. Huh?
Why are you playing? It's great.
We'll have like an hour of
At any rate, how did I, Carly? Yes, Donish. Is what? What's the pancake movie? Oh, No Pain, No Gain. That was a pretty bad movie. It's no Paul Bart Mall Cop. That was pretty bad. Okay, stop it. All of you know this trick, yes? Okay, well, Dan apparently knows the trick. Nobody else knew the trick? Okay, if you have a repeating number, it's over 9. So what would 0.12 repeating be? 12 over? Just 99. Okay? Everybody good? That's the trick. Now, I, of course, would like to show you why it works. All right? If I want this as a fraction, it has to be x over y, correct? And what do we know about x and y if it's going to be a fraction? They have to be what? Integers. Because it could be negative, right? They got to be integers. Okay? So, if there was no repeat sign there, it was just 0.1, what would it be? 1/10. Agreed? 1 is an integer, 10 is an integer. Everybody cool? Okay. Is 0.1 and 0.1111 forever? Where's the hungry alligator going to go? I have to say hungry alligator, because if I say greater than less than, you guys are going to be like, and all the people from other countries are going to be like, just put greater than or less than. And all the Canadian kids, the alligator's hungry, but I don't know where to feed him. He goes to the more food. Which means you still have to know which one is greater than the other one. So what symbol goes right there? An alligator, okay. An alligator goes right there. Okay, the alligator goes there.
Oh, yes.
Like alligator.
I agree.
Again, I ask you. I remember, let's get your grade 3 textbook out and flip to the section called alligators. There isn't one. What Yeah, okay, I was just going to ask. Some of you may have had a gamer nerd teacher who called it Pac-Man. Now, see, when I was your age, Pac-Man had barely been invented, so all the teachers were super old, and they always called it the alligator. I, of course, even in grade 3, was like, it's just an arrow. You just point it. Of course you did. Of course you did. The symbol that goes here is, of course, less than, because 0.1 is less than 0.111111. Very slightly. Agreed? Just like 10 cents is less than 11 cents. Everybody cool? All right. So, since this 0.111 is slightly bigger than this, I need to come up with two integers that will be ever so slightly larger than this. Right? Now, I can't change the 1 because it's a 1. So I need the integer down here that will be ever so slightly larger than 10. What is it? Has to be 9. Because in fractions, the smaller number on the denominator is the bigger piece of the pie, yes? If I have a pizza and I cut it in half. If I cut it in fourths. Everybody understand? So this has to be a 9 here because that is the integer, the only integer that is larger than 10. Does everybody understand? That is larger than 10 but that close to 10. Is everyone cool? That's why it works. All right? Because, of course, I like to show you why. Now, what about that one? What does it appear to be, Joseph? It appears to be 0.2 like that, yes? So make it a fraction. Not 0.2 over 9. 2 ninths. Right? And if I go to my calculator, indeed, what do I find out? 2 divided by 9 equals. Which is fun for me because I'm old and from Vancouver, and there used to be a pizza place whose phone number was 222-2222. Yes, back in the day before you needed area codes, when it was only 7-digit dialing, you dialed 222-2222, and they came on pizza 222. It was just like 310-1010 or whatever Pana is now. It's pizza that's 310-1010. What's Panagopolis? 310-0001 Pana. Anyway, doesn't matter. You can all know why I am so short and fat. I have that many pizza places numbers memorized. Now, you will also notice that I can no longer eat pizza, so I wasn't as good at having the numbers in my head because I no longer order as much pizza. Of course I make my own pizza, like I make 99% of all my own food, because I do not trust other people. I have worked in restaurants. I have seen steaks picked up off the floor and put onto plates. Yes, it is true. Yes. And those berries become jam. Now, to be fair, jam is boiled, so it should kill everything. And it is so filled with sugar, it kills everything. Because sugar also sterilizes stuff. What? Mystery diners? Yeah, I've seen mystery diners. Yeah. I don't need to see the show. I've worked in restaurants. I've seen it happen. All right. Now, back to business. Knowing everything you know now, and again, some of you might know the trick, look at D and tell me what you think the fraction might be. Donish. So Donish thinks 54 over 99. Well, let's have a quick check. 54 divided by 99, which is a perfectly legitimate guess, yes? When it was 2 repeating, it was 2 over 9. That gets me 54. But I don't have 54. What do I have? I got 54. Right? Okay. So, again, let's build on this. So, obviously, I can't have 2 9s on the bottom. What's your guess?
4 divided by 9 plus 0.5.
So 4 divided by 9 plus 0.5. Nope. Okay. What do I know needs to be in the denominator? I know I got to have a 9, yes? When it was 1 9, we had 1 9. When I said it was 0.12, what did we say it was? 12 over 99, right? Okay. So 2 digits, 2 9s. How many digits are repeating here? 1 digit. So how many 9s do I need? So I don't need any other 9s, do I? What number shows me nothing? 0. Okay, so there's my bottom, right? Now, again, I just did that horrible elementary school teacher thing where you call the bottom of a fraction the bottom. Of course, what should I have said there? The denominator. Or, in a bad Arnold Schwarzenegger accent, the denominator. Why aren't they hitting their desks? All right, so now, using it, yes, of course you may. It's just time when you have to learn something new for either you or Gervier to have to leave. Today it was you. I know it's not you, Gervier. That's why you're getting a thumbs up. And Austin is getting of course it's time for you to go. You'll notice your peers are all staring at the screen and writing down and looking at what I'm doing. None of them are in need of a pee or a drink. But, because they're about to learn something they've never seen before. But you, it's time for a drink or the bathroom. Go ahead. I know. Yes, I'm parched as well. That is why I, of course, bring drinks. Because this is not sub-Saharan Africa. I have all access all the time to water anytime I need it. Now, as I was saying, we're good here, yes? So through experimentation, 54 divided by 90. Still no good, yes? Now, but it gives us more information, doesn't it? Is 0.6 bigger or smaller than 0.54? Bigger, right? So that means 54 is too big to have up there, yes? I can't put 54 there, can I? Because it got me a number that was too big. Okay, so what else could I try? Now I know that this has to be lower than 54. So what could I start doing right now that is your people's best friend? This is what you always do. You just start guessing. So we know it has to be lower than 54, right? Well, let's go. What's next? 53 divided by 90. Because we're all cool with it being 90, right? That makes perfect sense. 53 divided by 90. Ooh. Oh. 52 divided by 90. Ooh. What is it? So through trial and error, which is how everything is originally discovered, we find out that it is 49. Now, you tell me, whenever we find something out in math, if it happens more than once, it is always going to happen, yes? So, if we could find this to happen again with another number, like, say, if we did, no, we'll do that in a second. You know it's going to happen again, right? If something happens all the time in math, there must be a shortcut, yes? There has to be a shortcut because you guys have spent your last 11 years learning math shortcuts instead of math, yes? 7 times 9. 63. 63. Right? You all have spent your entire life learning shortcuts. Rather than learning your times tables, you have been spending time, or the other one where you count knuckles. There's something there. I don't know what it is. You know why? No. There's another one for numbers. You know why I don't know what it is? Because I learned my damn times tables. Yeah. All those stupid things. Anyways. Yeah, hey, guys, Hannah has to pee. She wants to know where this is going. All right, so now, if there is a pattern, it must have something to do with the numbers, right? Like a squared, b squared, c squared. They noticed that pattern became a pattern using the numbers in that particular triangle. So there must be a relationship between 5, 4, and 49 that will give us the shortcut to doing this. Does anyone see it? No, maybe. Let's check. So that would mean 38, with that repeating, would be 89 over 90. It can't be, can it? Right? It can't be because 89 over 90 is almost 1, and this is nowhere near 1. Good idea, can't be right. When we tested your hypothesis, we found it to be wrong. Does anybody have another hypothesis? Aaron. Take the tenths, so the 5. So you're saying 54 minus 5 to get 49 over 90. All right, well, let's check. 0.38 with the 8 repeating. following your rules, that would be 35 over 90. Let's check. No, because he subtracted the tenths. 38 minus 3, right? 35 divided by 90. 0.38888888. Look at you, Aaron. Found your own shortcut. Now, that's a real thing. You just found the answer on your own without me having to tell you the answer. So, that's the shortcut there. Okay? You take the whole decimal, the whole numerator, as an integer, and you subtract the non-repeaters. So in this case, it was 54, the whole thing, minus 5, because the 5 didn't repeat. In my example, it was 38, the whole thing minus the 3, because the 3 didn't repeat. And then you put all of that over a 9 for each repeater and a 0 for each non-repeater. Everybody with me? So what then would be 0.123 repeating be? $121. No, not 123. The whole numerator, 123, minus the non-repeating part. What's non-repeating here? 12. So what's 21 minus 12? 123 minus 12 is 123 minus 12. The whole numerator, it's 111. Over what? 900. Not 9,000, you idiot. Okay? And just to prove it, 111 divided by 900. 1, 2, 3, 3, 3, 3, 3, 3, 3. Everybody cool? Yeah. All right. Go pee, because now we're on work. All you have to do, ladies and gentlemen, is these 7 questions, put them in the right category. The only one you might have trouble with is that. But you know what cube roots are. Go. When you're done that, it should take maybe 2 or 3 minutes. Remember how to use your calculator to find cube roots. Let's pretend. Did you even need to? Does 14 have a cube root? Is there a number times itself thrice that is 14? No, because 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So this can't possibly have a whole number cube root, can it? So it is irrational. What is the square root of 25? 5. What group does it fit into? Natural. Smallest group is all you need. What about that? Rational. What if I added those 3 dots? You would say it would appear irrational. Yes? What if I asked you to make that a fraction? It's 319,754 over what?
Over 9,999,999.
No, there's no repeatings. 100,000? A million. It's 319,754 millionths. Yes, and of course a 5 in front. Yes, to cover the 5. So it's really 5,319,754 millionths. Yes, good. Okay, what about this one? Oh, you've brought back exponents to mess with us, Mr. Myers. What is that really? It's 16. So what group is it in? Natural. Let's count, Zach. 1, 2, 3, blah, 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 blah. 15, 16, yay! 9, natural. What about F? Nope. You want to say irrational because you want to, but it's not. No. No. I've only told you what this is. I haven't actually written it down anywhere. Can you get a square root of a negative number? No, of course not. Why? What is a square root? Something times itself, right? So 2 times 2 is 4. So the square root of 4 is 2, because 2 and 2 are the same, yes? What two numbers could I multiply together to get a negative? You can't, because negative 2 times negative 2 is positive 4. And negative 2 times positive 2 is negative 4, but negative 2 and positive 2 are not the same number, are they? So this, the square root of a negative number, these, I was talking about them yesterday, are the imaginary numbers. And just when you think you've got a handle on the real numbers, you're going to have to learn imaginary numbers. Which is ironic, because even though they're imaginary, they are real. But they're not real because they're imaginary. Well, it's like the extra finger when you do this and go cross-eyed. You see that extra finger floating in the middle.
Yeah, you do. Ooh, you do. It's like, there's a thing that, like, I go to, it's like they give you there's like 2 diamonds and then there's like 2 left.
Yeah.
12 inside, you create 1 diamond with like all.
Yeah. Yeah. Or this one? Windshield wipers. But I don't have glasses on today, so it doesn't work. Anyways, so these are the imaginary ones. Don't worry about them until second year calculus. No. Second year calculus. University, second year of math. And what about that? Rational in appearance, yes? Because there is no way to know if the 473rd decimal there might be a 2. Okay? Everybody good? All right. Now, it will take you about 10 minutes to do this whole page. Okay? If that. I want you to pay special attention to actually explaining number 6. Be able to tell me why those answers are there. And of course, the answers are right there. Right? It is 12:30. Class goes until 1-ish. When all this gets done, we can have a little bit of fun because it's Friday. Oh, I have a little bit of fun. I rhyme all the time. I am an MC, clearly. I freestyle all the while. Nothing can stop me. Just you wait and see. Shut up! Yeah. Rhymes are over. Get to work. You really shouldn't. You'll look like a tool. It won't help you in the meet and girls department. Hey, Joe, what are you doing? Windshield wipers. Now, of course,